to talk about the intermediate value theorem.
Are we gonna?
Okay, no, we're not going to grade yet.
Okay.
Intermediate value theorem.
Just a second.
And right now, this is it. This you should have read in your book last night. If our function is continuous on a closed interval a to b, and if
Are we learning right now?
It can't equal.
right, it doesn't equal. And if f of a does not equal f of b, and k is any number in between f of a and f of b, then there exists at least one number c in a to b where f of c equals k. Okay. Now, what does that mean? This is what it means. Suppose we start out at the ground and we walk up a mountain that's 200 feet high. Would we pass through the level 100 feet? Yes. That's what that says. If we start out and f of 0 is 0, and f of, say, 7, that's 7 hours later, it's 200. Somewhere in between, we hit 100 feet. There was some time in between there that we hit 100 feet. In fact, if we walked up the hill and down the hill, there would be some time when we walked up that we hit 100 feet, and sometime when we walked down we hit 100 feet, right? That's the intermediate value theorem. That's all that says up there. It says, if our function's continuous on this interval a to b, and the first, like f of a doesn't equal f of b, and k is any number in between there, then somewhere along the line, there had to be a place that we hit that k. That's all it says. Okay, so, now, things like walking up and down a hill, that is the intermediate value theorem. But things like buying a cell phone is not. Like, suppose Maddie goes out and buys the very best, newest, and grandest cell phone tomorrow for $500. Okay? Now, 3 weeks from now, Maggie goes out and gets the same phone for $200. Okay? Because you know how this works, the cell phone. Is there any way that we can say for sure that somewhere in between there, between those 2 weeks, that it was $300? No, there isn't. We cannot actually say it actually happened. Might have, but it could have just gone from the $500 thing down to the $200 thing. Okay? But with a road, the road, if you go to St. Louis, you pass through a certain spot. If you take the same road back, you pass through that spot again on your way home. That's the intermediate value theorem. Okay, now, I want us to look at a couple of problems. It says that if we have this function, and this is our function, and it says that f of x is equal to x squared plus x minus 1. And this function exists between 0 and 5. It tells me that f of c is equal to 11. They want me to find the c. Okay, well, step 1 of this I have to find, this is the intermediate value theorem. They're saying somewhere along the line, in between 0 and 5, there was a k value of 11. And they want to know what c made that happen in between 0 and 5. So, what are the steps we have to take? We have to first say, what is f of 0? Because the first thing to prove the intermediate value theorem is we have to say, did this really exist at f of 0 and f of 5? So f of 0 is equal to x squared plus, or 0 squared plus 0 minus 1. That's negative 1. What's f of 5? 5 squared plus 5 minus 1. 25, 30, minus 29. Okay, so those two values did exist. Now, since they did exist, there's some place in between there, f of c, so that would be c squared plus c minus 1, and that f of c is going to be equal to what? Well, it's going to be equal to 11. So I'm going to say 0 equals, remember, you always have to make something equal to 0 in order to solve it. So now I'm going to say 0 is equal to c minus 3 times c plus 4. Yes? Okay, so c equals 3, or c equals negative 4. Well, look at our interval again.
Oh no.
It can't be the negative 4, it just has to be this one. Now, what if it had come out to be 2 and 3? Could they both be it?
Yeah.
Yeah, one would probably be when we were going up the hill, and the other one would be when we're coming down the hill. Okay? That's the deal on that. Okay, now, if I look in my book, somewhere I have this book, on page 80, all right, it says, they're asking you to find out where things are continuous also. Last night, like number 65. 65 says f of x equals x cubed when x is less than or equal to 2. It's ax squared if x is greater than 2. Now, in order for something to be continuous, what has to happen? It has to be where I don't have any holes in it, I don't have any jumps in it, okay? So, wouldn't the y from the left and the y from the right have to be equal to one another?
Yes.
Okay. Well, this is the y, f of x equals x cubed, from the left of 2. F of x, the y, equals ax squared, this is the right of 2. So they have to be equal to each other at that spot. This is our trouble child right here, 2. Okay, so
Q
we're going to say
squared.
2 cubed has to be equal to ax squared, but x is 2 in the trouble place.
Wow.
So I say 8 equals a times 4, so 2 equals a. Now, let's think about this. When I am at 2, this is supposed to be equal to 8. This guy would have to have a what? A hole at 8 that got filled in by him. Well, let's see. 2 squared is 4. A, we said, was 2. 2 times 4 is, gee, it's 8. So 8 would equal 8. So the one guy would have a hole there, and this guy would fill him in. So it works. So A actually is 2. Okay, there was one here that had 3 parts.
Yeah.
So that problem just wants you to see if it was continuous.
They want you to tell them what A was to make it continuous.
Okay. What if it could have been?
Oh, so
or was it?
No, they are.
They were-
You're making them.
So you're acting like it's a removable.
Yes, you are. You're acting like it's a removable. Okay, now, I want to talk about 56 from yesterday.
Why?
Because I said so.
Okay.
All right, 56. 56 you had on the other night's homework. And some people didn't get this right.
Oh yeah.
Yeah, in 1 minute. I'm writing and holding the book, so we have to wait a second.
Yeah, this was last night. So good.
okay, they wanted you to answer on this problem, are we continuous? Are we not continuous? What's the deal? Now, we're going to do this two ways. We're going to graph this by hand, and then we're going to show you how to graph this on your calculator. Because this is a piecewise function, and some of you do not know how to graph it on your calculator. But you can.
I'm one of those people. So is that.
All right, now, first things first is we take this and we say x minus 3 is less than or equal to 2, which means if the absolute value is off, it's greater than or equal to negative 2. So the x values available to me, for this part of the problem are 1 to 5. That's what I choose. Okay?
Wait, how did you?
Wouldn't it be still less than equal to, though, right? 5?
No, but you divided it.
I didn't divide by anything. I
Oh.
added the 3, and I added the 3. First, I had to realize that when it comes out of the absolute value, it is a negative 2 to this side and a positive 2 to that
So
side.
why is it a negative 2? Well, that's it.
Because that's what absolute value means.
How could it ever be equal to negative 2?
No,
Okay.
When you break it apart.
When you break apart an absolute value, how do you do it? This is an algebra 2 thing. I'm sorry if you missed that lesson. Okay? No, it's really not okay. Because an absolute value means x minus 3 is less than or equal to 2, or the opposite. X minus 3 is greater than or equal to negative 2, which is what this says. That's what that means.
Okay.
And it's very annoying that you guys don't know this stuff. It's like, well, I took it into my brain for a half a minute, but you didn't learn it. It's time to start learning things, which means you take it in there and you keep it in there. Okay, and it's not somebody else's responsibility to remind you every year what you don't know. All right, so we have 1, 2, 3, 4, 5. And these are our x's. Now, what are our y's equal to? Our y's are equal to cosecant of pi over 6 times that x. So, I have cosecant of pi over 6. I have cosecant of pi over 3. I have cosecant of pi over 2. I have cosecant of 2 pi over 3. I have cosecant of 5 pi over 6. Okay, I put the values in, that's what I get. Now, what are these equal to? What is the cosecant of pi over 6? All right, 30 degrees. Think about it. Here's 30. 1, 2, radical 3. What is the cosecant? That would be 2, because it's hypotenuse over opposite. Okay, so this one would be 2 over radical 3. This would be equal to what? 1. This would be equal to
4,
2 over radical 3. This would be equal to 2. I should not have to draw this picture. This is 120, so this would be 60. Right?
Yeah.
So this is radical 3, this is 2, this is negative 1. Sine and his reciprocal cosecant are still positive in there. And I would have, if this was 120, the cosecant of 120, which is 2 pi over 3, by the way, is what? 2 over radical 3. Okay, so if I were to graph these, we have Let's see. What is 2 divided by radical 3?
1.15.
Okay. So if I am at 30, I am going to be up here at, do we want to say this is 1, this is 1.5, this is 2, like that?
Yeah.
Okay, so here I have, at 1, where are you?
2.
We're at 2. At 2, where are you? About 1.15. At 3, we're at 1, and then we go back up, right? So far we have this look thing. All right, now, what happens for the other part? What happens for this part? Well, we have f of x equals 2 when what? The absolute value of x minus 3 is greater than 2. Okay, so now, how do you do this? This guy, x minus 3 is greater than 2. So x is greater than 5. So when x is greater than 5, I am at 2. So it will be a line going like that. All right, how about, then I have x minus 3 is less than negative 2. So that means what? X is less than 1. So when I'm less than 1, I am at 2. Okay, so there we go. We have our nice little picture. All right, now, calculators out. It's a what?
It's a ramp.
Oh, a ramp?
Yes.
Okay. Now, step 1. Go into y equal. All right, here we go. Now, really, you really have to listen to what I'm saying. Parentheses, and the parentheses are a biggie. Parentheses, 1 divided by, parentheses, sine of, parentheses, pi times x, right, divided by 6. Okay, now, if you notice here, I have 1, 2, 3, 4 parentheses, right? Which means on the right-hand side, I have to have 4 of them. 1, 2, 3, 4. All right, now. No, that's 4. Okay. Now, we need this to be when? When we're in between 1 and 5, right?
Yeah.
X has to be less than 5, but X also has to be greater than 1. And you don't want to put greater than or equal to. Just listen to me. You don't want to do that. So, we're going to say, parentheses, X second math. And we're going to say, X is greater than 1, parentheses. And then we have to put another set of parentheses and put X, second math, go to less than 5, parentheses. Now, X is bigger than 1, and X is less than 5, right? Okay. Now we have the other two parts, right?
Yeah.
Okay, go to the next line. We put parentheses 2, parentheses. Like I said, the parentheses play a big part in this. Okay, then I say parentheses, X is less than, so I do second math, less than 1, parentheses. third line, parentheses, 2, parentheses, another set of parentheses. X is second math greater than 5. Right? Wasn't it bigger than 5 and less than 1, right? I do not know if I can put those on the same line. I really don't. I know yesterday it worked without putting them on the same line, so I'm sticking to it. Okay, I know this works. Okay, now, I am going to do Zoom 6, or standard. There we go. Okay, so it graphed the whole thing for me. Do you see it?
I know that'll dot too.
Yeah.
Yeah, it's because we turned the line thing.
That's because
We did that one thing at one time, at one place.
you have to use dot mode on this calculator. On 83, you have to use dot mode. What it's doing is, it's dropping, Casey, Kenny, it is saying, okay, I stopped here, it connects it to the x-axis. Okay, I'm starting here, it connected it. If you put dot mode, it'll look dotty, but it will, or in your brain you have to say, I really don't have little lines there.
How do I get to
Okay.
That mode.
Oh, wait.
You have to go to mode, I think, and hit dot,
Yeah, I'm on.
not connected.
I'm on dot.
Okay, then I don't know. It's just a glitch. But I mean, it's a lot of these things they fixed with the 84.
So if we want to be on dot.
See, ours, I'm on connected and it's working fine. But theirs in an 83 and it's dropping these little lines from here down to the x-axis. Okay, so I'm just saying that's what it's doing. And like I said, on the 83, the 84 took care of some of those problems that we had. Okay, but I think that's neat that you can do a piecewise function and see it. Okay, so this is everything that you needed for last night's stuff. Okay? All right, now, we're going to talk about today's.
That way.
All right, so. All right, now, we need, this is very easy. We've done this already.
I'm still scared. I know.
Okay.
Caleb, what's funny is that you know how Andrew yesterday he did blinded actually did it.
Why? For what?
What now?
He made
Right?
All right, we're gonna grade both our assignments tomorrow. Do not forget, by the way, that tonight is enrollment.
Oh, it is?
Tonight, if you're, did you sign up for tonight or Monday?
I don't remember signing. I think when my friend signed me up to work, that Monday or so I don't remember. I mean, I can do it.
but yeah.
All I know, that's a long time ago.
Ditch me like a bazillion times.
All right, Munchkin. This is, we're going to talk again about limits and vertical asymptotes. Infinite limits and vertical asymptotes. Now, we need to find the left and right hand limit as x goes to 4. Guys, you really need to do this, not with a calculator. We need to engage our brains and do this. Okay? So, we are quite capable of this.
My brain says
At one time,
that one time.
I tried, but my brain hurt.
I want to learn. I want to learn so I don't feel stressed at home because I don't know how to do it.
Alright, I don't want to hear you whining either.
Oh, that's not whining. I said I want to learn.
It sounds like whining. Okay, now,
That's just my natural voice. Sorry.
no, it's not.
We're saying we're
Limit as x goes to 4 from the left. Now, this is what you have to get in your head.
Oh, well.
You take a number to the left of 4. But I know you guys keep making fun of me when I say this, but it's supposed to be something like I mean, we have
We deal with-
Okay.
Okay, so you're gonna have this. Oh, okay. And you have to think about this. Okay? You want to be super duper close to that 4 on the left hand side of it. Now, if we get that close, what happens? Mark, talk to me.
If it gets that close.
What kind of number am I going to have?
Yeah.
What?
No, it's gonna be big. It's gonna be negative. Boom.
Okay, well, okay, I'm going to have a negative point.
So confused.
I think what he's saying is, where do we get to after this, right?
Yeah.
Okay, so I have 1 divided by this teeny weeny negative fraction. So what happens? It's going to be a very big number, but it's going to be negative. So we go to negative infinity.
Did we square that or no?
Okay, I can square that. Ooh, that's going to change things. Sorry. She's right. We didn't square it. We need to.
Oh, I thought you were being sarcastic.
No. All right, now, if we square it, if you square it, what happens?
It's positive.
We get positive infinity.
There you go.
Okay, good job. All right, now, what's going to happen on the other side?
It's gonna be a teeny tiny toilet.
Oh my God! Oh my gosh!
So it's the limit.
All right.
It's the limit.
Yes. Well, we're approaching a really great big number.
And that's what I wanted to find, the limit from the right and left.
Yeah, we want to find. We just found the left. Now we're going to find the right.
So is this one from 4.0000000?
Yes. This is when we put in 4.000000 dot dot dot. Eventually, there's a 1 there, right?
Yeah.
Okay. Now, what happens this time?
It's a really small positive number on the bottom.
Correct.
And then you square it, it's still really small.
And it's still.
No.
Okay, it's positive infinity. Now, once we know that on the left and on the right we got infinity, that proves.
There's a parabola.
It proves that when we're around 4, what did we do?
Went up.
Went up.
Right, went up. So that proves we have a what? What is this? What is this thing? Vertical asymptote. It proved we had a vertical asymptote. So we have a vertical asymptote at x equal to 4. All right, now, somebody, we're going to talk about something else.
Oh no.
We need to talk about horizontal asymptote.
Whoa.
Okay, horizontal asymptotes, they occur when the limit as x goes to infinity of our function goes to some value c, and the limit as x goes to negative infinity of our function goes to some value c. So that value c would be the horizontal asymptote. Okay, now, let's go back to this one. What is the limit as x goes to infinity of 1 over x minus 4 squared? Now, we have a little gimmick to solve these.
4.
Yes, we do. I just heard Paige. Paige said 0. Why? Exactly. Exactly. Okay, this guy up here, she said, she looked at this, and this is P over Q. And she went back to that pink piece of paper we learned when we were doing this algebraic.
I gotta find it.
And we said, exactly, we said that if the degree of the top is less than the degree of the bottom, we automatically go to, that looks like it,
pretty big though.
Okay? Says if the degree of the top is less than the degree of the bottom, we automatically go to a horizontal asymptote of 0. Now, what I told you guys is if you were, suppose you were taking an AP test or a, I don't know, a club test at college, and they asked you for this. To prove that you have a horizontal asymptote, you must do the limits. So, in other words, you have to show them this. Do I have to do a whole bunch of algebra? No. I know my rules. So I know this goes to 0. I just have to show these two statements so that I'm using calculus to prove it. Okay, but in your brain, you're using your algebra. That's why I keep telling you, remember all the different things we taught you. Not just one way, no, 4 ways. It's okay. All right? All right, let's see what else we need to talk about here. Oh, goody. Find the vertical asymptotes. Okay. All right, we know tangent has problems.
I should guess what it is.
All right, guess. What do you think it is?
Pi over 2, so it's
Okay, now.
pi 2 pi n
All right, now.
plus pi over 2.
In his brain, he's thinking, I know the normal tangent graph goes like this. All right, so we know, and he keeps telling us, he was saying, I have to add. Okay, but this graph here is y equals tan x. This is not this.
So you have to.
Okay, so we need to know when is this angle going to come out to be pi over 2? Because that's our problem, child, right? He's our problem. So how can I find out when this angle becomes this?
Pi over 2 equals.
Okay?
Hi, Miss Adams.
Miss Adams, I have to finish this and then...
She'll be here till this afternoon.
Okay,
Bye, Miss Adams.
all right, so we have pi x. We've got to make this equal to our angle so we can find out where it happens the first time. Mark said it's going to happen, and then I'm going to add pi to it, I'm going to add pi to it, I'm going to add pi to it. So this is my angle. We want this angle the first time. Find out the first time he came out to be pi over 2.
What do you do? What do you do with the piece? What do you do with it?
No. We want to know, we know that the tangent of pi over 2 is where this asymptote happens. Okay, so what Mark said is, I got to figure out where that happened first. Okay? So he's saying, okay, I'll make my angle equal to this, and I'll figure out where the first x was that happened. Okay, so when you solve this, what do you get? Half, okay. 1/2 is equal to x. All right, now,
Look at that next one.
Oh my god.
okay, now think, or think about it this way. We said pi over 2 divided by pi, or we said pi times what would give me pi over 2, 1/2. All right, so we're good with that. All right, now, how am I going to talk about what Mark said? He said it doesn't just happen at that first
Isn't
spot.
it like that?
You have to do
Plus
pi.
Okay, but, okay, this guy was pi over 2. What was this? 0. What's this guy?
3 pi over 2.
3 pi over 2.
3 pi over 2. All right,
guy over there.
so how much am I going to have to add to this to get there?
She's a straight.
Wait, it's different right over. You're confusing me.
All right, to this. Guys, pi over 2, yes, I have to add pi. But now we're not in that, we're in 1/2. How much did you add? How much do you add to get from 1/2 to 3/2? 1?
Or 2 halves.
2 over 2.
or 2 halves. Alright, and then the next one would be where?
5 pi over 2.
Wow.
5 pi over 2. So talk to me, what am I gonna do here? I'm gonna say x cannot be what? 1/2 plus,
Pi k.
okay,
Plus 1.
Yeah.
Plus 1.
Yeah, we do.
1k.
Plus K.
Plus 1k. Or
k.
Plus Y.
Remember, it's multiplying by the pi. That's what the girls have said. It's multiplying by the pi. So I need to just move along. Okay, we have to add 1 to it. How about if I subtracted 1? Where would I be?
same place, but on the left side.
Okay, if I said k was -1, I would have 1/2 plus -1. So that would be -1/2. So when I put -1/2 in here, I would get negative pi over 2. So this works. So k has to be an integer, right?
Yeah.
That one's hard because of that pi being in there.
That'll be the homework.
It could be on
That'll be
homework.
It'll be a harder version.
Alright, now,
Be like
what
pi
are we doing with
over
this
4.
one?
So, how is that different from what I said to me? Like, how
You had to change it, Mark, from
Move on.
this
Oh,
pi
I
over
understand.
2.
yeah.
You had to change it and say it's a 1/2. Like, normally, if we had tan of x, when you said to me, I can't be pi over 2 plus pi.
Yeah.
Every time. And I kept going k pi, k pi, k pi. The only problem is this guy already has the pi in it. So we have to figure out, how am I gonna get the 1/2 in there? Then how am I gonna get 3 halves in there? And how am I gonna get 5 halves in there? Because you know the places, you're telling me the places, but you're telling me for that guy. Okay, that's the difference between what you were telling me. Alright, now, how about this x?
You take a 4 up top.
Factor in.
Can we factor that?
How we spell?
Yeah, take
my
out
life.
4.
You can take a 4 out the top and the x out the bottom.
Alright. On the top,
4
I'm gonna take a 4 out, and what am I gonna get?
x squared plus x minus 6. And then that goes to x minus 2.
6?
Yeah.
Okay, whoa. Hold on a second.
Take an X out of bottom.
How about this? X cubed times x minus 2.
Holy
Huh?
moly. Whoa. Oh, you're doing
-9 times,
Oh, that.
or -9x, sorry, -9x. How about -9x times x minus 2? What do you think?
Yes.
That's cheating?
Cheating.
It's false. Whoa.
Cheating.
Okay, now, what did I do?
X plus 3, x minus 2 on top.
Hold on.
Yeah.
Hold
You
on.
can
So
cancel
they
out.
cancel
Don't do
out.
that.
They really do.
Flip them.
No.
I know, but wait a second. There are people who did not get the bottom part yet, okay? Some of you said, oh yeah, I remember that. But other people are like, what just
Oh,
happened?
I remember you like divided into like 2 separate.
Okay. So, on the top, everybody took out the 4, everybody was happy.
That's how
On the bottom, I looked at this and I said, gee, there might be a pattern. Somebody did say we could have taken out an X, but I'm not sure that really would have helped us. But by doing this, by looking for patterns, and what I usually do is I try to pick 2 of them. So I pick the first 2, and then I pick the last 2 to see if I saw a pattern. Sometimes it doesn't work that way. Sometimes it's the first one and the third
I was
one,
gonna say,
the
keep
second
first and
one,
third
and the
going.
last one. I
That's where
mean,
mine's
you
not.
gotta look for the patterns, okay? So, we took an x cubed out of here, and we have an x minus 2 left. Now, what I tried to do is say, if I could get an x minus 2 here, it would really be nice, wouldn't it?
Yeah.
Okay, so what we did is I took a -9x out, then I got my x minus 2. because now someone said on the top, I can have 4 times
X minus 2.
x minus 2 times
X plus 3.
x plus 3. And on the bottom, first step is I'm going to have x cubed minus 9x times x minus 2. Because what did I do? I factored x minus 2 out of both of those. Okay, now can we factor some more? I think I should have used this start over.
Squared plus.
I'm just rewriting it first because I need more room.
Yeah.
All right, now, what can we do?
You can take
They got the.
Okay, 4 times x minus 2 times x plus 3. Can I do any more factoring?
Yes,
on
you
the
can
bottom?
take the x to the third minus 9x and take an x out, so it'd be like
Oh, then you get x squared minus
So
9.
this is x times x squared minus 9,
Because then
right?
that's x
Yeah,
plus 3
that's
is
why
minus
x
3, so you
plus-
cancel out the other.
All right, so now I'm going to have x times x minus 3 times x plus 3 times x minus 2. Now, okay, now we finally finished factoring. Yeah, it took us a while. Now, first things first, I start removing factors from the top and bottom. What does that mean?
Can't be.
there's holes.
There's holes
They're
there.
removable.
And they're removable discontinuities, okay? So, if I now factor x minus 2 and x minus 2, that means x equal 2 is a whole. Right? It's a whole. Alright? Now, next.
X plus negative 3 is like holes.
Okay, x plus 3, so that means x equals negative 3 is a whole. Now talk to me about what's left.
So we got
4 over x squared.
Okay, so someone's writing this again. They're saying I've got 4 over x times x minus 3. All right, now I want to know about,
that giant thing.
right, now I want to know about 2 things. I want to know if I have a horizontal asymptote. Okay, I do. I have y equals 0 because numerator less than denominator. So y equals 0, I could do a limit as x goes to infinity, a limit as x goes to negative infinity, and prove that. Now, talk to me about the bottom. Do I have any vertical asymptotes?
No.
Yeah.
Oh,
Right
x
here
is
it is.
3.
Yes, 30.
X equals 0, x equals 3. Now, because if I put a 0 in there, what happens to the bottom?
Sometimes.
It becomes 0. I'm not allowed to be that. If I put a 3 in there, what happens to the bottom? It becomes 0. Not allowed to be that. Okay, now, to prove these, what do I have to do? If I do calculus, I have to do a limit as x goes to 0 from the left, and a limit as x goes to 0 from the right, and I have to do a limit as x goes to 3 from the left, and a limit as x goes to 3 from the right. Okay, so this problem required a lot of work.
Yeah.
Okay, because we have to remember a lot of our factoring. Okay, now, when we do these limits, we're going to get what? We're going to get either positive or negative infinity. This one, when I go to infinity, Paige already told you, you're going to get 0. I really think Paige knows those rules off those newspapers, and I think some of the rest of you need to learn that. All right, now,
So what's up?
our test is still on Monday. Now, write this down. Remember to review, and this review, remember we're going over that review Friday. I sent that out on that reminder. You're supposed to have been working on this.
I have.
Okay, but this is tonight's, and And this is going to infinity, talking about asymptotes, all that kind of stuff.
Sure you don't want
Right.
to change that to even once into 76? You sure?
Yeah.
What now?
Do it. Do it. Do
Pull
it.
the trigger.
No. I want you to do all of them. That's why I sent it out on Monday night.
Back of the book.
Hey,
My book got caught in the snowstorm.
All right, now, guys, we're gonna go over page 80 tomorrow. That was that first stuff that we did. Right, let's do that. This is 88. We're gonna break both of them.
okay, I'm gonna be gone tomorrow, so what do I need to take out? Okay, so
Tennis tournament.
Chest turn.
that's the junior varsity one.
Oh, okay.
He's on.
So
What time do you? All right, tomorrow's Friday, so Monday's the test. Know your stuff. We'll put something out there and look at the video. See if I go with review questions. If you have time before you go, bring it home. We'll bring it. We can get it when you get back.
I only speak about 7 points.
Oh, all right.